So the question you can see says solving system by elimination, part 2. Tomorrow, part 3, just more practice with eliminating. So nothing new here, just more practice. So it says here's an equation. It says perform each of the following operations in answering the questions. What does each result in equation look like? Is it still true? Okay, so the first equation, what does it want me to do? Timothy, what's it say to do?
Add 12 to each side.
Okay, so that's what we're going to do. We're going to add 12 to each side. We're going to see if it still works. So on the left and the right, I'm going to add 12. Work? What do I get on both sides? Yeah, 63. Is it still true? Yes, absolutely. How about if I add 10 plus 2 to the left and 12 to the right? So the left I'm going to add 10 plus 2. The right I'm going to add 12. Still going to work? Yep. Still true. It says add 4 plus 3 equals 7 to the equation. So I got 50 plus 1 equals 51. How about if I would add 4 plus 3 equals 7? Will it still work? Well, what do I have total on the left side? 54, 55, 56, 57, 58. Right side is 58 as well. It says write a new equation. That one added gives us some that's also true. Okay, so you add something to both sides, that will make it true. And then for B, do the opposite. Which one?
Numbers or C?
C?
Yeah, numbers.
Yeah, look at the numbers on the left. 54, 1 and 3 is 58, right is 58. I got 58 on both sides equal sign.
4 plus 3.
Hey, okay.
I'm just.
I was waiting.
Okay, what do we got? What do you add? Everyone sure?
20 to each side.
20 to each side. So 51 plus 20 would be 71. 20 this side would be 71, that's fine. Okay, can we add something to each side? That won't be true. What can I add to both sides?
Oh, 50 more, or 50 plus 1 plus 2 is not equal to 51 times 2.
Okay. It does say added to, so I got to add on both sides.
Oopsie.
Yeah. So the only way that that's going to happen is if you come up with an equation that's not true, right? Because if you have 2 plus 1 equals 3, if both sides are true above it, they will get the same thing on both sides. If I add something that's not true, so the only way it's not going to be true or false is if you add something that isn't true. Because if you start balanced, you do it to both sides, it's going to stay balanced. 15.2. The teacher purchased 20 calculators and 10 measuring tapes for her class and paid $495. Later, she realized she didn't order enough, so she placed another order of 8 and one more measuring tape and paid $178.50. Okay, number 1, in this situation, what do the solutions to the first equation mean? Okay, so what does C represent? What does M represent? And do the same for B. How many possible solutions do you think there are? And what does the solution mean? Why don't you just answer everything for number 1, and then we'll share together. All right, let's talk about the first one. What does C and M represent there? Yeah, cost of calculators and measuring tapes. That would equal $495. Second equation, calculator and measuring tape cost to equal $178.50. Now, do you think the prices are the same? Okay, if you've ever bought anything online or in general, can you get a discount if you buy more? Yeah. Usually, right? So how many possible solutions are there? Well, there should be one solution for that one to equal $495, and there should be one solution for that one. That would equal $178.50. Okay, what does a solution to the system mean? Okay, a solution to the system would be the price combined. Okay, if you have more than one equation, that's called a system of equations. That would basically be a total cost. An average cost of the calculators, an average cost of the measuring tape that you ordered. So that's what we're going to do for the next one. It says find the solution. That means a total. That works for both of them. So we could use substitution, we could use elimination. We're going to do more elimination on the next page. So let's just graph this one. So let's just plug it into Desmos. X is going to be our cost of calculators. Y is going to be our cost of measuring tape. So I'm just changing the X and the Y's from the C's and M's, so just plot that in there. And then we will be looking at where they intersect. So go ahead and bring up Desmos. We'll just graph this one. Those are the two equations. Yes, Georgia, you got it?
Yeah,
What do you got?
21.5,
Remember, that's my C.
yeah,
Okay.
and then 6.5.
So the calculators cost $21.50 on average. And the measuring tapes were $6.50. Okay, number 3, it says to be reimbursed, the teacher recorded items purchased. Total of 28 calculators, 11 measuring tapes, equals $673.50. Can you write an equation that represents the total?
28C plus 11 equals 673.5.
Yes, very good. How is this equation related to the first two that we wrote down?
Same thing, but just different price, different number.
How's it related to these? Just added together. The sum of the first two. What would the solution mean? Well, it would be the average cost of calculators. And M would represent the average cost of measuring tapes. How many solutions does it have? Why? Yeah.
I mean, cause like, if you put in any other numbers, it won't equal that.
Yeah, there's only one way it's gonna equal $673.50. Any other combination is not gonna equal the total.
Well, if you. Never mind.
There's only one cost that makes sense. As you saw when you graphed it, they're only gonna cross in one spot. Okay. Solve these without graphing, then check your solution. We can check it by graphing if you want. Again, elimination, substitution is not gonna matter, but when the signs are the same, don't substitute, just eliminate. It's gonna make life easier for you. So question A, can I just add those two together?
Yeah. Yes.
Yeah, they are opposite signs. So Amy, how many x's am I gonna have if I add those together?
One.
No, 0. 2x minus 2x is nothing.
Well, but like.
Nothing, no x's. If you have 2 apples and eat 2 apples, you have nothing.
Wouldn't you just put it next to it right though?
Nope, you would not. I mean, you can cross it out if you want.
So there would just be no X.
Nothing. How many y's?
7,
7 y's. And?
21,
So then you should be able to get y.
3.
3.
3. Is that my answer?
No.
Part of it.
Part of it. Jordan, what do I do with it?
Put it in one of the other.
Yeah, put it in either one you want. If you want to deal with the negative 2x, put it in there. If you don't want to deal with the negative, put it in the top one. I'm going to put it in the top one. 2x plus 3 times y. What's 3 times y?
9.
3 times 3 is 9. Next,
Subtract 9.
subtract 9. 7 minus 9 is negative 2, so x is negative 1. Okay, since you got Desmos open there, why don't you just check it? Type those into Desmos and see if you get that point where they cross. Yeah, so How easy is that to check? Pretty easy, right? Pretty easy. Now, if it does say use the elimination or substitution, you gotta show this work, because you can't do that in your head. B, easy, right? Can I just add them up?
Yeah.
Yeah, that's really nice when you can add up and they have opposite signs.
But you.
How many x's I got?
5,
5x. No y's equals
10.
10. So x is 2. Half of my answer. Plug it in. Top or bottom doesn't matter. I'm going to do the top. I don't want to deal with the minus again. So 2 times 2
4.
plus 3y equals 7. Subtract 4.
3,
So y is,
1.
so your point where they cross is 2, 1. We don't have to check any more of these. When you get to your homework, you can to see if they're right. Question, Caleb?
I was gonna ask, it doesn't matter which one you solve for.
Does not. Does not. Next one. Ooh, tough one now. I can't just add them. I gotta do a little work here.
I can add it.
Because I'd get 4x and 7y. I want to eliminate one of the variables. So what do I gotta do?
Subtract.
Subtract or
Change their sign.
change the signs on one of them and add again. I prefer that. If you like subtraction, so it's 2x minus 2x, 3y minus 4y, 5 minus 9 if you want to subtract.
But then you're gonna get negative.
Yeah, you're going to get negatives either way. So I'm changing all of them to a negative and I'm going to add them together. X's are gone. 3y minus 4y is negative y. 5 minus 9 is negative 4. So what does y equal?
Negative 4.
4.
4. Negative y equals negative 4. Positive y would equal positive 4.
Oh, whoops.
Again, I'm going to plug that into the top one. I don't have to deal with anything else. 2x plus 3 times y is 12 equals 5. Now what?
Minus the 12.
Minus a 12,
7.
negative 7. So x is negative 3.5. All right, D, the first one where we've really had to do some work here. I can't add, I won't eliminate anything. This is the first one where we haven't had the same number. Okay, so you have to decide, do you want to eliminate the x's or the y's first?
X.
I want to eliminate the x. So I need these to be the same number. So what is the first thing that 2 and 6 both go into?
2.
The least common multiple of 2 and 6. If you were going to do a common denominator,
12,
okay, you could do 12. 6 would be the easiest, right?
I guess.
Least common denominator of a, if it had a 2 and a 6 in the bottom would be 6. You could go to 12.
Yeah.
So I want this to be 6. So what do I got to take the top equation times?
3.
3. So I'm going to take the top times 3. And what am I going to get?
40.
There you go. So I took the top times 3. Why can I do that? Because I did it to everything. Now, do I want this to be a positive 6 still?
Yep. No. Well, it doesn't really matter.
You keep that.
Negative.
Yeah, I'd like it to be negative so I can add them and they'd be gone, right?
No, you can just.
Otherwise, you could just subtract again.
But then negative 5y turns to a positive.
So I'm going to take everything times negative 1. And I'm going to show that. Times negative 1, times negative 1, times negative 1. If you want to subtract, you don't have to do that step. So how many x's I got? 0. They eliminated. That's what I wanted, right? Y's?
14.
Equals 28.
So y is
2.
2. Plug that back into either of those equations. Again, I'm going to choose the top one so I don't have to worry about any negatives. 2x plus 6 equals 16. 3 times 2 is how I got the 6. Subtract 6.
Y equals 5.
10.
X equals
X equals 5.
X, Y, section.
You could have eliminated the y's. If so, I would have taken the top one times 5, get 15. Bottom one times 3 to get negative 15, and then added them that way. Doesn't matter which one you
But
choose.
then you gotta deal with the negative.
Yeah, I mean, we had to deal with negatives anyway.
Well,
The benefit of doing that is I wouldn't have had to take it anything times a negative 1.
right,
You would get the same answer.
but yeah.
All right, next question. Last question, page 264.
Over 1056 there.
Oh, sorry. Add the first two equations. See if you can do that. And we'll see if we agree. Okay, that should be enough. 3y, x's are gone, right? 2y and y is 3y. 2z minus z is 1z. 7 minus 14 is negative 7. Now do the same to the second two equations. Bottom two. Add them up. Gotta write the whole thing, though.
I understand how you do positive and negatives, like adding and subtracting and all that.
Just think, you're like, just think apples, and taking away apples and then giving back apples.
I don't want to think about apples.
And think about pears.
Chickens.
Peaches, cows.
All right, should have 2y plus z equals negative 4.
Cause like,
Negative 3x and 3x are gone. Y and y is 2y. 2 minus 1 is 1. Negative 14 minus 10 is negative 4. Solve. All right, let's combine those. Let's eliminate. Can I just add these together?
Yes.
Nope.
Why not?
Nothing will eliminate. I'll have 5y and 2z. No letters eliminated. That is bad.
Subtract.
Subtract, sure. Or take it times a negative and add.
You're gonna get one y.
You want to just subtract, that's fine. Let's try a subtraction. 3y minus 2y.
what's y?
Z minus z. Nothing. Negative 7 minus negative 4.
So how do you do that? What's that? Negative 11.
It's negative 11, it's 3.
Here's your issue with subtracting. That's a lot of negatives to look at, right? Negative 7 minus a negative 4. Write it out. Two negatives in a row make a plus.
Yeah.
Negative 7 plus 4, negative 3.
That is weird to think.
That's a lot of negatives.
Confused.
See, how does that work then? Cause you're taking away negative 4 apples.
It's the same as adding. You're basically getting apples.
And you're eating them.
All right, which one do you want to plug it into?
Probably.
Top one? 3 times negative 3? Negative 9 plus something is negative 7. 2. You'd add 9. All right, so I have y and I have z. Now we need to get x. Let's plug it into everything into the top. 3x plus 2 times y. 2 times negative 3. 2 times negative 3 is negative 6. Minus z. Minus 2 equals 7. 3x plus a negative 8 or just minus 8 equals 7.
Plus 7.
I don't want to touch the 7. Here's my x.
I meant plus 8.
Plus 8.
Equals negative
My brain's
7 plus 8 is 15.
Plus 5.
Oh, yeah, okay, yeah.
X equals 5. So your solution to that one would be x is 5, Y is -3. Z is 2. 3 answers.
Isn't Z, your Z is like your, like on a graph, wouldn't it be like point below what it goes to?
3-dimensional, yeah. All right, question on your homework, page 266.
That's a lot of people. You have to do that.
Question number 1. Should be simple. The elimination should be easy on that one. 2, circle word all. Circle word all for number 2. 3 is the same thing we did with the calculators and the measuring tape. Question number 4, multiple choice. Question number 5, circle the word all again. Question number 6, I'd like you to do one of those by hand. Which one do you want to do? Top one, so please substitute or eliminate. If you want to graph B, you can. That one looks like an easy one to substitute as well, though. Question number 7, personal question. Personal opinion, I should say. You want to add or subtract? Why? 8's a review, box and whiskers, we got those down. 9 and 10, we can handle those. All right, so the rest of the time you have to work on those.